Review of Integration Formulas and Techniques by Justin D'Souza. The learning objectives of this lesson are to compute integrals using direct computation and rules, to compute various integrals using integration by substitution, and to compute integrals using completing a square before integrating. The keywords in this lesson are: let us go through the basic integration formulas which we have already seen before. Now, let us recall through them. You can just pause the video now and go through all of these. There are exponentials, tan, trigonometry, and these are inverse trigonometric functions. When you integrate these, the answer would be inverse trigonometric functions. Now let us look into this problem here. We need to evaluate integral of sine ax dx. Now, before we start solving this, we should see that it is not a direct problem because there's a constant term with the variable. Now, if it was integral of sine x dx, the answer would be very simple. It's negative cosine x plus c. This is the answer. But we do not have any formula for ax when the coefficient a is there. It's not going to be just like this. It's going to be different. Now, whatever the answer we solve will be like a formula. If you see any more such cases, you can directly write the answer once we derive it. How we solve such problems is by U-substitution. It's called U-substitution. Here you can see this ax is a problem. Why? Because we know the formula only of sine x dx, that is negative cos x plus c. But now if we remove this and say if we had made it integral of sine m, and then with respect to m itself, then I know the answer would be minus cosine m plus c. This is possible. So this u substitution is simply just this itself, but instead of m, we will have u over here. But we don't know what is dx equal to, because I can't just tell, okay, let's put this as u and this as du. No, this is wrong, because I have no clue what dx is equal to, right? But we can find it out. All we need to do is we need to equate u is equal to ax. Now, this is the u substitution part. Whatever is the variable, all these, both the terms, you just make it u is equal to ax. And now derive both the sides. It's going to be du is equal to, a is a constant, right? A cannot be equal to 0 because this will be all 0. It doesn't make sense. A is any number other than 0. Leave it. It's a constant. And dx. Why? When we derive both the sides, what happens? The constants are left alone. This is what happens. So now this d means derivation, right? So du is equal to a times dx. Now here I can substitute sine instead of ax. What do I substitute? U, because I'm assuming or substituting ax as u. But now what is dx? I know du is a dx. So just take this to the other side. Du is going to be, du by a is going to be dx. So dx is du by a. So instead of dx, I'm going to write du by divided by a, and a is constant, so I can remove it outside directly. So I'll just take this out, 1 by a integral sine u du. Now then I can easily use the integral formula of sine. I'll just write over here sine x dx. This is minus cosine x plus c, right? I will apply the same thing, but instead of x I have u. That's fine. So it'll be not integral, it's going to be minus cosine x plus c. Why these brackets are there? Because it's multiplied. 1 by a is multiplied with the negative sign. So I'll just take the sign outside. It's minus 1 by a cosine x plus c. Guess what? This is our identity. In the future, if at all, I mean, if this is the question and it's in writing, then obviously you need to do in detail. But otherwise, you have, say, integral sine 3x dx. You just can use this formula. It's going to be 1 by 3, negative 1 by 3 cos x plus c. That's it. That's the direct answer. So this is an identity. And you can see over here the steps are also there. First is the formula which we are going to use, and then we do u substitution. That is, u will be ax. And then you just Okay, you do not need to take x to the other side and derive. First, you can just derive both the sides. It's du is equal to a dx, and then dx is going to the other side, and you just take this to the other side. Yeah. Okay, now I realize what I was trying to say over here. You can derive both the sides over here with respect to x. That is what it is. When you see, it's u is equal to ax, right? You're deriving both the sides with respect to x. So the derivation of u becomes du by dx. A is a constant, remains, and this over here is dx by dx, which is basically 1. So this is what you will get. Du by dx is equal to a. But even if you understand, you just derive both the sides, that's also fine. Whichever is easy for you, you can just follow that. And then what's happening over here? We get dx value. Now substitute back in this equation. Instead of ax, you have u. Dx is du by a. And now this a is constant, so remove it out and use the integral formula. It's minus cos u plus c, and you get this as the answer. It's very simple one. Now I will give you one more problem here. Just change this. Instead of sin x, do it for cos ax dx. Obviously, a cannot be equal to 0. Please pause the video now. Try this by yourselves, solve it by yourselves, and then I will solve it over here in a while. I hope you have tried solving it. If not, please then pause the button and try it out. How do we solve this? Just like what we did over here, let's recall the formula of cosine x dx. It is positive sine x plus c. So we know this will be the answer. So all we need to do over here is assume ax, u is equal to ax. And you can take x to the other side, but the simple way is du is equal to a into dx. And what is dx? Du by a. The same thing what we did just a while ago. And now instead of dx and ax, we substitute in the question. See, this is the question, right? Over here we substitute u and du by a. Now this a is a constant, so 1 by a integral of cosine u du. You can easily solve it up using the formula. That's going to be sine x plus c. Remember, this 1 by a is not multiplied to the c. That's a constant anyways. It's just over here. You just add c to the end. And now that's the identity. If you have a as any number, you can directly use this formula. I hope you all solved it and got the correct answer as well. So only when it is sine over here, integral sign, it'll be negative over here. But we know integral of cosine will be positive, so that's why it's positive. That's the answer. Don't forget to substitute back. Okay, I have forgotten to substitute one important thing. This is supposed to be u, I realize now. And after finishing up, substitute what you initially assumed as. I assumed u to be ax, right? So I substitute back here. It will be ax plus c. Okay, I was a bit sloppy. I hope I didn't make the mistake earlier as well. Remember, when you get that minus 1 by a cos u plus c, if I've written x, please remember this was supposed to be u. Now here, what is the u value we have assumed? It is to be ax, so we substitute instead of u, the ax value. As you can see here clearly, it's substituted back. That is important. The next type of problem reminds us of trigonometric function. If you recall, this is 1 by 1 plus x squared, like this, right? What is the formula for this? It is tan inverse x plus c. So all we need to do is get this in terms of tan inverse x. I mean this term, and then we can solve it out. So you can see this constant is there. This must be removed outside. How do we remove it? Now just let's focus on this. If I want to remove this outside from, this is a single term, right? Both are together. Now imagine I put this bracket and I want to remove this out. What's gonna happen? There's only one, right? If I remove this from these both, over here there'll be only one. Or the better way to understand is I will divide over here by a squared, so I'm gonna get 1. This is what I want. But I can't do just one side. I have to even divide over here. And don't forget, I have to even multiply, because when I multiply here a square, Then over here also a squared. See, now what happened is this cancels. It's 1, 1. I have not done anything wrong. I have just manipulated the numbers, isn't it? So this is mathematical manipulation just to get what we want over here. So now here, this I will cancel and I'm gonna get a square is remaining, yes, but this is gone. Over here, let me keep this. I have a square, x square, a square. So now I can remove this a square and a square outside. So it's gonna be a square out. There is 1 remaining because they are got cancelled, and over here there'll be x squared by a squared. So this is what happens. Now I can use this formula here because this x squared by a squared is square. Then we can do u substitution and solve it up. Now there are many ways to understand this. Let us take 1 by a squared plus x squared once again. Now look here. What I want is I want to take this out from here. So I will remove this out. What happens? Over here there was a square, it's gone, so there is only 1 now. But here, is there any a square? No. When there is no a square at all, you can't remove it. So basically it's division, it's becoming division over here. So now if I multiply this a squared inside, I'm gonna get the above term. If I multiply this over here, it's going to be a square, and if I multiply it over here, it's going to be a square divided by a square. It will only be x squared. So it's balanced. I have to keep it balanced. So this is how I get it. Now once I get this is all integrated, right? Integration. This is a constant. A square is a constant, so I can remove it out. So integral 1 by a square. Remember, it's in the numerator, 1 divided by. So it's 1 divided by over here. And over here also, this all terms will be in the denominator. So it's x by a the whole square. Now this is the term we have. All you need to do is use substitution. So over here, u will be equal to what? This entire term. X, sorry, it's not x squared, it's just x by a. Now you can take this a to the other side, it will be a u is equal to x. Derive on both the sides, it's du by dx. And now I know, over here I forgot to write dx. Whenever there is integral with respect to what? dx. So this dx is a du. So I can substitute over here 1 by a square as it is. Integral 1 by 1 minus what happened to x by a? It is u, and square it up. And what is dx? Dx is a. Over here we have that has gone to the other side, so it's a into du. So this is a constant a into du. So this is what happened. Now let's integrate. This is a constant, so I can take this out. So I can bring this out over here, or I can just cancel the square and over here. Up to you. So I'll just bring it out over here. A by a square integral 1 by 1 minus u squared du. I can cancel this and this. So I'll have 1 by a integral 1 by 1 minus u squared du. Now we know the integral of 1 by 1 minus, sorry, it's all plus. I'm so sorry, I don't know why I've written minus. It's all plus. There is no negative sign at all. We have just taken out, and it's all plus itself. It's plus x squared dx. What is the formula for this? It's tan inverse x plus c. So here, instead of that, we have 1 by 1 plus u squared du. This will be equal to, this 1 by a will remain. I'll just write below, 1 by a will remain. This term becomes tan inverse u into a plus c. Now don't forget to substitute back what was u. 1 by a tan inverse x by a plus c. This is the answer. Let me just quickly run through this again. First thing is, when we have terms like a constant term here, a squared plus x squared, we have to remove this a squared. So then we can use tan inverse formula. But how do we remove that? So what we need to do is basically here, integral, this a square is removed out, right? 1 remains, and this doesn't have a square, so we divide it by a square. Or you can think of multiplying and dividing by a square both the sides, and then removing out, cancelling. Whichever is easy, you can follow that. Now here we have simplified this. the constant 1 by a square integral 1 by 1 plus x by a the whole square. Now this somewhat looks like this formula here. We can use tan inverse formula. But before that, we have x by a, right? We can't take two terms. We can't have constant. We need to substitute this as u or any constant. I can even take this as n. It's fine. But generally we take it as u substitution method. Now here, the a is constant, goes to the other side. This doesn't dissolve. Why? Because it's a constant and this is the variable. Just write du over here, dx, and this remains. If it was plus here, then this would have been 0 and only du. But we are multiplying. The constant is multiplied or divided. That will just remain there. And then we know dx is what? A du. So substitute back, instead of this original equation, we can take it as 1 by 1 plus u squared du. This a and a cancels out. So it's something like this over here, which we have. And now here we can just use tan inverse formula. But instead of x, we have u, and then we write it like this. The last method is substituting what we had assumed initially for u value. That is back over here, and that's the answer. Once you start solving these by yourselves, it'll be much easier. You can see that is the answer. We've got 1 by a tan inverse x by a. The substitution is very important, plus c. That's the answer. Here it's done in detail. Now, if you're thinking why we have written a squared, basically we're multiplying and dividing it. That's it. And then only this is multiplied, divided over here, and that will remain and then cancels. Whichever method is easy regarding this simplification, just follow that. Now here we have a minus b the whole squared formula. Looking at this, what comes to my mind? There is no formula of square, whole square. So it's only about a minus b the whole squared. I mean, there is no integral for power 2, like this whole power 2. So I know that I have to substitute this and use this formula and expand it. So this is a squared minus 2 times ab plus b squared, right? So what's going to happen here? Instead of a, I have x squared, and instead of phi, I have instead of b, I have phi, then whole squared. So here a squared, but already this is x squared. So x squared times 2, because x squared the whole square becomes. So it'll be x power 4 minus 2 times a is x squared, b is phi plus phi squared. Here I can write it like this, x squared the whole square. And now here the simplification is x power 4 minus 10x squared plus 25. So here this integral of x power 4 minus 10x power 2 plus 25 dx after expanding. Now we can integrate these directly, right? Each term can be integrated. It will be x to the power 5 by 5. The power rule says you need to add the power by 1 and divide by the final power which is formed up. And here we have x power 3 by 3 plus, if there is no variable, then you just add x. And at the end we have to just write plus c. So this is the answer. It's a simple one. X to the power 5 by 5 minus, don't forget the sign, this is minus, x power 10 into x to the power 3 by 3 plus 25x plus c. A simple problem here. And we go to the next one. This is the last one. And here, looking at this, I can think of the formula. It's either sine inverse or cos inverse. Let's look. So integral 1 by square root. This is minus x squared here. So I should have 1 over here, constant. This is what? It's sine inverse formula. Sine inverse x plus c. Now I know this is the formula, but I need to rearrange it. How can I rearrange this? The only way I can do is by completing the square. So let's think about it now. Here this constant, that's fine. We can deal with it after some time. But these two terms, we need to make it as square. How we can make them square is by completing the square. So I'll just take this much only over here. So I'll just check minus 5 plus 6x minus x squared. Okay. Here, this constant, let it be over here only. And completing this way, this must be first. So I'll remove this minus sign outside. And I'll write x square first, and this becomes negative 6x. What did I just do? I just rearrange these terms and remove the minus sign outside. Now, in case I multiply this inside, it's going to be the same, isn't it? Why? Because it's going to be minus x squared, minus and minus is plus 6x. So nothing is wrong here. It's just rearranged. Now, do you remember the completing the square method? You do not need to use the formula or anything. There's a shortcut for this. I'll write it over here. Minus whatever is the square, we have to make it a whole square. So what happens is, this entire thing is one term. This x squared, just write it as x. Over here, don't write this x. X is gone. But this, whatever number, the sign remains. If it's minus, minus, plus, plus. But this number must be split into half. I mean, just divide by 2. 6 divided by 2 is 3. And this thing gets whole squared. This is completing the square. But it's not over. You need to subtract whatever this number is there. Square it up. This is the direct method. Now, if at all you are x squared plus 8x, the completing the square method would look like this. X plus 4 the whole square minus, doesn't matter it's plus or minus, it's always minus outside the square of this 4 squared. So this is how we do completing the square method. So now we did the same thing here, and now let's simplify this up. Minus 5, this minus sign, into x minus 3 the whole square, and this minus and minus, this becomes plus. 3 square is 9. Now let's simplify it further. Plus 9 minus 5 will be plus 4 minus x minus 3 the whole square. But we have simplified. Yes, we got the square. Now we can use U-substitution. X minus 3 will be U square. But the problem is this 1 over here we have 4, right? So we need to simplify that as well. So what do we do here? Now whatever is this over here is inside the square root. So how do we get it as 1? So I can just remove this 4 outside. I'll remove it out. Just a while ago we did it. So what remains is 1 minus x minus 3. Now remember, it's whole square, but there is no term, no 4 over here. So I divide this by 4. Because I removed the 4 out, okay? And this is the thing. Over here, there is one problem. Sorry. This square is only for up. I have written it down. So now this square is only for up. It's not for the 4. But we need to write this entire term together as a square, right? See, how it works is, I remove this 4 out. Okay, fine. Over here, 1 remains. Over here, there was nothing for this term. You just divide this term by 4, not the entire thing, okay? I mean, not inside this. You just divide this entire thing by 4. You don't put a 4 inside the square root because that's not possible. Now it's balanced, but the problem is I don't want this 4 here. I need it as a whole square. That's fine. 4 into 1 minus, this 4 can be written as 2 square, isn't it? This is 2 square and this is square. So entirely we can write it as x minus 3 by 2 the whole square. That's it. Now if I square this up, the above term gets squared, x minus 3 the whole square, and down it's 4. Yes, it's balanced. But still it's not over. This is all in the square root, right? Now we don't want this 4 inside the square root. Let's take it out. The root of 4 is 2. So 2 goes out. And what remains? This 1 remains minus this entire term, x minus 3 by 2 the whole square. Now we can see the square root is like this, 1 minus x squared. I mean, this entire thing is squared, so we can arrange it. So whatever over here the square root was there, this is the simplification. So now I can write this as 1 by this 2. Since it's outside square root, I can write it away over here, 1 by 2 also. I'll just write it over here. And what is remaining? It's 1 minus x minus 3 the whole square dx. So this is, these two terms are the same thing. The question is rearranged and written like this. Now let us do the u substitution. We need to assume u to be x minus 3 by 2. Why is that? Because this entire thing to be u. Let's take 2 to the other side. It's 2u is equal to x minus 3. Let's derive throughout. It's going to be 2 du is equal to dx. What about this? Here when we derive a constant minus 3, it's going to be 0. It's minus 0. We just don't write it. So dx goes to be 2, becomes 2 du. And what about u? U is x minus 3 by 2. So here 1 by 2 integral 1 by square root 1 minus u square, x minus 3 by 2 square. And what is dx? It's 2 times du. Now this half and this cancels off. You only have over here 1 by square root 1 minus u squared du. Now you can easily apply the inverse formula, trigonometry sine inverse. This was just looking like the one might, if it was x squared and over here x, then it's sine inverse x. So the same thing, we just have to do sine inverse u plus c. But don't you think it's not the same? Yes, absolutely, it's not the same, because we had a weird over here looking thing, right, equation, but we rearranged and everything. So what's the difference then? The difference is very simple. This u becomes sine inverse x minus 3 by 2 plus c. So that is the answer over here. So now if you're thinking, okay, we can directly write this formula, is it? No, because we don't know what is u. So all the steps which you did was to find the u value. Now this is the final answer. To solve this, you need to write sine inverse x minus 3 by 2 plus c. It's not sine inverse u, because u can be anything. We have to substitute the u back. Now if you solve this up, I mean, if you integrate this, you should get this as the answer. So that is done by all these steps, the substitution, this not only the u substitution, the rearranging, completing square, and all these methods finally give us this as the answer. So you can see the steps here. We know it's sine inverse, it's related to that, but we have to first complete the square, and we get this over here, and then we substitute it back over here. Instead of this, we substitute over here and we solve it up, and we have to solve by u substitution. So u is x minus 3 by 2, and then we have over here du by dx is half, and 2 du is equal to dx. Substitute everything back here. Now what happens is this half and 2 cancels off, and you're remaining only with this term, which is sine inverse u plus c. But that is not the answer. This is our answer, that is sine inverse x minus 3 by 2 plus c. It's a bit lengthy. Please do practice problems, do similar problems, practice them, and you will get a hang of it. So that is the end of this lesson. I hope you found it helpful, and I will see you all in the next video.